This is the first video in the series going over VRVex. VRVex is a website that allows you to program a virtual robot using the Vex platform. It's pretty much based off of Python, but it uses code blocks so that if you have experience with computer science, you can do Python coding for the program for your robot, or if you have no experience with programming languages or anything like that, you can use the code blocks to do so. So I'm just going to kind of quickly go over the overview of the user interface. Website's pretty simple, straightforward. Up here in the top right corner, you have your languages, your file operations. So you can start a new blocks project. If you want to do in Python, you can start a text project. If you have a file project saved on your computer or your device, you can open it through here. Here will give you a history of your different files that you've uploaded on here before. You have examples so that if you want to kind of learn more complex features of how to do the robot, you can kind of go through these examples, get an idea how that works. You can save your work, you can save copies of it. And if you go to tools, this is to kind of change the appearance of it. So classic, it kind of gives it a kind of hard to kind of distinguish from a distance. If you change it to standard, it's a high contrast version of that. So it makes it a little bit easier to see your text. Um, and then you have your tutorials as well as learn, which will take you to a website to kind of go over more in detail how to do different activities and use the advanced functions of the robot. Okay, so let me get out of this tab real quick. Okay. All right. And the middle top screen, you got your undo, redo. So if you make a mistake, you can go undo. If you go too far back, you can go forward. Vex Code project, you can change the name of the file type so that maybe if you're doing exercise 1, 2, 3, 4, it kind of makes it a little bit easier to kind of understand what you're doing. Not logged into class. So this is basically if I set up a virtual classroom, I can give you the assignment so you can submit it or get the information for the details. We're not really going to do anything with that. Then you have your playground. So the playgrounds allow you to do virtual maps to test out different codes, and certain maps will have different robots, so you can actually do more advanced functions. Open the playground allows you to open up your existing playground so that if you close it by accident or anything like that, it'll make it pop back up. Once you have your code set up and run it, you would go ahead and click on Start up here. You can also do is break it down step by step, so that helps with your troubleshooting. If your code is not behaving the way you want it, you kind of go through line by line to see where it's working fine and where it's not working fine. Okay. Your Share button, this is pretty much where you'll put your name, the assignment, and if you want to add notes, and then you can download that file, the project to go ahead and submit that. Okay. Right below it, you have your code viewer. So basically, as you write out your code, it will pretty much establish what it looks like in Python. So that way, like if you are more comfortable programming using the blocks, you can do that. And then if you're using something that only does Python, doesn't support the code blocks, it'll translate it for you. So you can then copy and paste it into that programmable environment. Your serial monitor allows you to see what the sensors are saying, what your variables are, the values of your variables, and in the console will be like if you want to have your robot communicate with you. And then your help, basically when you have a block selected, it gives you details about it. So you have the pretty much explanation what it does. Then you get an example how you use it. And then it has a function. Some of them will kind of say something like switch Python. Supposedly that's for the premium version of this. So basically you can use this if you know the Python commands, or if you want to learn Python little by little, you can kind of substitute those blocks for these. Okay. So what we're going to do is going to select the playground, and then we're going to go ahead and select the art canvas as our first example. I'm not going to save the work. So there we go. And let's go over the playground window. So up here you have your shrink to maximize, minimize, or shrink it down and make it larger. If you want to kind of work on your code, you don't want to see that, you can click on hide and show to bring it back up. Activities, we basically, again, like some things you can do with the map. And then if you want to get it out of the way, you can close that out. And again, if you lose it, you can always hit open playground and bring it back up. Right under it, you have your data table. So you can click on that. So it kind of gives you GPS coordinates of your robot. What are the sensors looking at? So you have two sensors, one looking forward, one looking downwards. Its position in terms of X and Y, the angle of the location, not really sure what that means. Bumper, so it has a left and right bumper, and then the distance sensor, what it's picking up. Okay. To the bottom left, you got your play, so you run your code. This is to reset your map, and then you have a timer to see how long it takes your robot to do your sequence of code. On the right hand side, you got your cameras. By default, it's the top down view, so that's this camera right up here. The left one, that is your first person view, so you're pretty much seeing what the robot sees. And then you have your three-dimensional view. So it's going to allow you to rotate your camera to kind of get an idea of what your robot looks like. Again, depending on the playground, your robot may be slightly different, but this is like a standard Explorer version of the robot. So as you can see, it has four motors. So two on the left, two on the right. And it pretty much that is the drivetrain. The program already kind of has that figured out. Later on, when we actually build an actual physical robot, we had to figure out what is the size of the wheel, the distance from the wheel centers on the front and back, as well as left and right, in order to properly calculate the distance so that when we program a robot to go a certain distance, it goes to that exact measurement. Here, right in front, you got the vision sensor, so usually it detects distance. There's also one right under it, so that's this one right here. You have your bumpers, so you have a right bumper, you have a left bumper. And then you also have a marker or a pen used to draw your maps. And then there's a magnet in there somewhere, so you can use that to pick up objects on a different map. Okay. So let's kind of quickly go over the basics of programming. Basically here you have your different categories: drivetrain, magnet, drawing, sensing, console, logic, and switch. So again, switch, we're not really going to do too much. This will be if you want to learn more about Python. If you remember from programming with the Arduino, you can see that the shapes are very similar, the colors are very similar. So if you remember how to do most of that stuff, this right here is going to be pretty much familiar territory.